Okay, thank you very much. We have very little time, so I want to first of all introduce Fred. Fred Warner is the Chief of Strategic Engagement Department at ITU. Welcome, Fred, to give the opening remarks.
Hello. Let me start with a question. What if the last thing that humans ever invent is invention itself? Now, what do I mean by this? We had, if you're familiar with Roman Yampolsky, he's a leading AI safety expert. And I met him in New York at the UNGA last fall. And he said, Fred, what is AI for good? I said, well, what do you mean? He said, well, is it for good or for good? Well, what do you mean? And he said, well, for good as in beneficial, as in good, or as in for good, forever. I said, good point. And he said, what if AI is the last thing that humans ever invent? Now, you might agree or disagree with that statement, but it's not hard to imagine a future where most future inventions will either be invented by an AI or with the help of an AI. And if that is the case, then I think we do need to make sure that AI, if it's going to be for good, is indeed for good. So my name's Fred Werner from the ITU. It's the United Nations Specialized Agency for Digital Technologies. And we're also the organizers of AI for Good with 50 plus UN sister agencies. Now, AI for Good was created in 2017. And if you think about that, that's basically an eternity in terms of AI years, looking at how fast it's been developing. And back then, it was really all about the fear and the promise and the hype of AI. Most solutions existed in fancy PowerPoint slides, but there wasn't a whole lot of substance. But that changed rather quickly. In 2023, we saw the advent of generative AI. Last year, the unofficial theme of the summit was the rise of the AI agents. And now we're looking at a world where you're basically entering a zero-click world where agents are not waiting for our prompts. They're actually acting on our behalf. And in addition, you have the physical embodiment of AI in the form of robotics, embodied AI, brain-computer interfaces, and we're even looking at space AI computing now. So I think it's safe to say there's no shortage of high-potential AI use cases that can be used to help solve global challenges. Anything from affordable healthcare to education for all, food security, disaster response. The use cases are definitely there. So what is the goal of AI for Good? Well, simply put, it's to unlock AI's potential to serve humanity. And how do we do this? Well, first of all, we can't do this alone. Nobody can. That's why we have 50 UN sister agencies as partners of AI for Good, contributing knowledge, sharing expertise, helping to drive our standards work, building cooperation around AI governance. And we're very privileged to have here the two co-chairs and facilitators of the UN AI Global Dialogue, who will be doing the closing remarks. Now, I could talk about AI for Good for days, but to save us some time, I just want to show you a little video so you can actually see AI for Good in action from our last summit. If we could please play the video. I have a joke that I always save for these occasions. AI is easy, AV is difficult. Actually, we don't need to see the video. Is it going to happen? Yes. But now we need sound. Since there's no sound, that's lovely Geneva.
Aha. Okay.
We are more than the AI generation. We are the generation that is determined, ladies and gentlemen, determined to shape AI for good. So no matter how fast technology moves, let us never stop putting AI at the service of all people and our planet.
If we want an AI literate society, meaning resilient and ready for the future, we need to integrate these new tools into school curriculum.
Let's build a future where AI advances progress for all humanity. A shared digital future that is again inclusive, equitable, prosperous, and sustainable for all.
It is no coincidence that this era of profound innovation has prompted many to reflect on what it means to be human and on humanity's role in the world.
AI must help bring us closer, not to divide us apart. That's one of the foundational promises of AI for good.
We all now have, I think, a much greater level of awareness around AI, and we all need to shift into that as fast as possible because this technology is moving so fast.
Ladies and gentlemen, this was a real fast-track operation that we did, what we call the International AI Standards Exchange Database.
Push for standards in your domain or industry that require this type of rigor.
Started the last fight of the Junior Division. Let's go!
I think it's fair to say that AI for Good is indeed more than a summit. It's a movement, it's a global community, and it would be nothing without you, the participants. 3, 2, 1.
Thanks for watching. I'm not sure who that last guy was, but no, I think I think people often misunderstand that AI for Good, it's known as a summit that takes place each year in Geneva, but it's actually a year-long activity. We have online events almost every day of the week, all year long, and we're organized around 3 pillars: solutions, skills, and standards. And if you look at the solutions pillar, we have machine learning challenges, we have startup pitching competitions, all types of activities to identify real practical applications of AI that you can use here and today. And on the topic of Edge AI, we had a build-a-thon on Edge AI just a few weeks ago here in India, and we also had machine learning challenges on tiny ML, tiny machine learning devices. And when we're looking at skills, we launched the AI Skills Coalition, and a big piece of that is going to be creating basically machine learning environment sandboxes where we can do training and mentoring for governments to upskill their constituencies on the use of AI using the data from our machine learning challenges. So it's not hypothetical, it's using real data for real solutions. And the last piece, of course, the bread and butter of ITU is standards. And we have over 400 AI standards published or in development covering a whole suite of topics. But more specifically related to the session, we have a standards work on future networks, basically 5G, 6G, and beyond, and a pre-standardization effort on AI native networks. So basically, these are examples of AI for Good in action. And the theme of this session is actually Edge AI in action in the Global South. And I'm very much looking forward to the discussion, and thank you for your time and attention.
Thank you so much, Fred. Now we have the keynotes coming. Thank you. First of all, let me call Professor Lal. Brijesh is my great friend as well as colleague. He was the Bharati School chairman, but also right now he is currently looking at Edge AI research. Our touch points with ITU are many, where he is hosted AI for Good challenges, WTSA hackathon. He was a judge as well as Kaleidoscope. He is very active. Thank you very much, Vijay, for coming, and over to you.
Yeah. So it's been a while. Thank you, Vishnuji, for having me. That I've been participating in these AI for good activities. So there's been a lot happening, not just these talks that you have, but also something on the ground. Hackathon is an example of that, with participation from all over the globe. So today I'm going to talk about some of the work that's happening here at IIT Delhi, where we're trying to leverage the edge. And the other thing that I'm going to run through very quickly is TSI and its role in edge. So because we're focusing here on accelerating development across the global south, so I'm going to pick up those two examples today. Right. So what we're trying to say is that you have lots and lots of edge agents that will now act simultaneously and in coordination. So the reason why edge is becoming more and more important is this converge of communication, compute, and control. And this convergence is now quite real, and because this convergence is real, it is enabled, at least in today's technology, only by a strong edge. Controls specifically for tasks in the area of haptics, as I will show in the next slide, require you to not miss or make mistakes, because some of them are catastrophic. And for that reason, strong development in the area of edge is important. The other reason why looking at edge is important from the perspective of global south is that while it might not be easy to have foundation models that solve all the problems of the world, at least to an extent, context has become increasingly important in modern times. People want to provide solutions which are very, very specific to the task at hand, and context can be best leveraged or used if there's a strong edge capability that is present. So in that light, it's important that the global south focuses on building its strength in the area of edge. This slide here talks about some of the work that we're doing with respect to haptics. Haptics, as you know, is this sense of touch, primarily consists of two aspects. One is kinesthetics, which is the pressure that we feel, and the second is tactile or texture, which is the quality of surface that we, the fine-grained texture of the surface that we are able to measure using our skin. So the thing with this kind of a modality is that while it seems to be almost absent, it is quite pervasive. It's all around us. The temperature, including the hardness, the softness, or the way people meet each other, greet each other, all of that is very, very important. We just don't, it's not overt, but it's important nonetheless. So we sort of take it for granted. However, it is very, very important, and therefore it needs to be looked at a little carefully. Now, the challenge with haptics is that while as we move from speech to video, people did talk about bandwidth and they did talk about latency, and there were quality of experience measures that evolved. With haptics, it goes to the next level, because if you have unsynced and delayed haptic inputs or feedback, then it becomes quite confounding, and it confuses the person, and it sometimes can be quite disconcerting. So for this reason, it is extremely important that the haptics data that you receive is accurate and received on time. So for this, it becomes extremely important that there's a strong capability that's present at the edge. Now, here at IIT, we're trying to implement it using two ways. One is what we term as split control, where we've tried to move from having solutions deployed only in the cloud and the endpoint. We try to put in significant amount of capability on the edge itself. The other aspect that we're looking at carefully is trying to convert signals which are haptic in form to signals which give you the intent, rather than actual measurements of pressure, as what haptics is to machines. So these two things are primarily handled at the edge. The first one is quite clear. Let me just say a few words about the second. So when we talk about intent, in today's world, whenever you look at a haptic solution, it's sort of locked in right from the operator to the end point, where you'd have some kind of manipulation, dexterous manipulation of the environment around the device. However, it's very, very hard for devices of different manufacturers to interoperate. And this happens because it is very, very tightly coupled to all the signals that are generated and the form factor of the devices. It's not as simple as pick up any camera and the image that you get, you can show it on any display. So for that reason, the idea is to convert those signals into intent, send the intent to the other side, and the edge on the other side makes sense of the intent and converts into a signal that the other or the far point can then use to do whatever works needed. So these are the two things that we sort of look at with reasonable amount of interest at IIT Delhi, and we continue to contribute to standards primarily in the area of MEC and quality of experience where multimodality is involved. Right. Now this is the Edge Foundation Network. I'll skip this in interest of time because I do have a couple of slides that I want to walk you through, because there's some work that's also being done by TSDSI, which is our SDO here in India. And they have, in conjunction with ITU, doing quite a lot of interesting work, which is edge-centric. So let me talk about a few of those. So there are a few technical reports that have come out of late. There's this talk of dynamic AI ML models for self-sustainable V2X applications. So V2X applications is being looked at carefully. There's also work in the area of security aspects and advanced and AI enhanced massive digital twinning initiatives. So we have some technical reports that have happened in this area. There's also developing of standards work that's happening. There's architectural support for tactile applications that I just spoke about. There's talk of 6G AI architecture for RAN and also AI native scalable reference architectures. I think maybe we'll talk about quality of experience in the next slide, but that's another thing we're looking at. We're also carrying out technical studies in all of these areas. In interest of time, you'll have the slides, you can go through them when you find the time. This is the other thing that they wanted me to bring to light to this audience. Yeah, just a couple of minutes. So the global standard forums that are of interest to the audience here, people who look at Edge carefully. There's ITUR IMT 2030 framework for included ubiquitous intelligence for overarching design. And then there's ITU-T related standards. There are 3GPP standards, and of course the one M2M. So all of these standards are of interest to the audience there and people trying to do research in this area. And besides this, TSDSI has been trying to be inclusive by holding these flagship conferences, annual ones, so that more and more people get insight into what's happening. With that, I'll close because we're really short of time here. Vishnuji, back to you.
Thank you, Bajeshji. Thank you for bringing out the Indian research in the topic and bringing out the Edge AI framework also. It's very less time. Let me invite Ranjita. Ranjita obtained her PhD from IISc. Her current research involves causal inference, survival analysis, and Bayesian neural networks. Over to you, Ranjita.
Yeah, so something that he also missed, I actually do work in federated learning and many other learning paradigms. So let me just start. So mine is going to be a technical talk where I'll tell you the motivation for using federated learning, especially the role of federated learning in telecom networks, and why really are people discussing about this. The motivation is, of course, data explosion. There's exponential growth of in mobile data traffic, and you have all these diverse services that are there in 6G, eMBB, URLC. I'm sure this audience is well aware of this. Then there are bottlenecks in these legacy networks which actually motivated moving more towards edge-centric architectures. The goal is, of course, I think this is something very important that most of the standards are looking at: predictive, zero-touch automation, closed loop wireless control, and this loop closure latency requirement about less than 10 milliseconds for mission critical optimization. And this is exactly where federated learning comes in as a key enabler of privacy preserving and distributed intelligence. So all of this is captured in the AI native network concept, where now AI is no longer a peripheral layer, but it's actually coming into the RAN, right? So this is enabled by what is called as this ORAN alliance, particularly the RIC or the RAN intelligence controller. And this is how the whole sub 10 millisecond latency requirement is fulfilled. But something that is not very clear here is why do you really require edge intelligence, right? So to make it even faster and achieve this sub 10 milliseconds, you actually have to bring in inference and training to the edge rather than taking data to the cloud, right? So that's where the whole paradigm shifted, and this argument about edge intelligence or edge native intelligence came in, and especially something called as MEC or multi-access edge computing also was introduced. So this brought in a huge architectural change. That is, now we have the core network talking to RAN, and then RAN talking to the to the UEs, and this is where the whole, the UEs basically now have the intelligence along with the MEC controllers. So federated learning. Upon all these things, one very important aspect, that's how we relate to AI for good, is that of privacy, right? So think of the use case of traffic prediction, where there is, there's a need for loads and loads of data, but this data consists of raw user logs, location history, or I mean, if you share it with the centralized controller, it's just privacy violation. So the solution is to now bring code to the data and not take data to the code, right? So that's where federated learning comes in. The intelligence now, or the training, happens at the edge, and only certain metadata is given to the cloud. So what is its implication in telecom? So there is impact on privacy. That's exactly where it's supposed to make the impact. And then, of course, there's impact on latency and bandwidth. So personalization of AI models is possible in real time. Large-scale training can still happen in the core network, but the personalization of smaller models for localized applications can happen actually at the edge. And there's impact on bandwidth because I no longer need to send data to the server. And of course, there's a huge impact on architecture, because you saw there that it becomes a hierarchical style of an architecture where core network is at the top and UEs are at the bottom. Okay, so I just wanted to quickly introduce two use cases. In fact, it's in fact a use case from France. This is for a traffic prediction. In fact, predicting certain traffic spikes when they had a football match. And this scenario is where you need to allocate dynamically resources for this particular stadium event. So here what's happening is each of these UEs or base stations are picking up the traffic in their local area, sharing it with the core network, sharing it with the MEC controller, and then the core network is able to say how to really route the traffic so that there's less congestion. The other one is V2X. So this is again for sharing road conditions or accident information and other things. It's very easy to see why FL may be useful here. Each car can talk to its own edge server and then go to the cloud server where the global model is trained. So this sort of envisages how federated learning has become a very important technology. So last but not the least, I'm the PI of the lab which is called as Intellicom Lab at IIIT Delhi. We have a collaboration with IIT Delhi for this entire work on federated learning on systems, and this project is funded by MEITI and the India AI initiative. This is actually more of a security use case. I'll not go too much into the use case, but we have built a very similar, it's a prototype of the federated learning use case that I just showed you, where we have like a main server, we have some federated clients, and we are looking at certain security incidents that happen only at one client. The client picks it up, and then now the entire network knows about the possible security issues that can come up in such scenarios. And we have some couple of publications on this. I'll really not go into this. Thank you so much for the opportunity, and please do visit our exhibit, which is at Hall 2 in MEITI Pavilion. Yeah, thank you.
Thank you, Ranjita, for the excellent talk. We had an introduction at least for federated learning, and also the framework, that architecture that she explained is really interesting. Last time when ITU colleagues were here, we had visited the lab. If you haven't done that, please talk to her. It's a very exciting research which they do. And we also have great collaboration with Bapi and colleagues in IIIT Delhi. Thank you, Ranjita, for coming. We have a panel now. We have approximately 20 minutes maybe for the panel. Let's kick off the panel. Can I invite Fred to moderate the panel? And can I invite the panelists, Mala Alagan and Sakshi to please take the seats. Fred to kick off. Thank you very much. Over to you, Fred.
Thank you. So I'm looking forward to this panel where we can aim to demystify Edge AI a little bit and explore the practical use cases and AI strategies. But first I'll introduce the panel. So the first panelist, her name is Mala. She has a full name, but she personally asked me to just call her Mala. And I wish all panelists would do that. It's much easier that way. So Mala is currently a technologist at the Center of Excellence, Wired and Wireless Technologies at Art Park. Prior to this, she was a postdoctoral research at the Teikiang Group at Technical University Berlin. She's also involved in 6G initiatives such as AI RAN for efficient resource allocation and millimeter wave communications. And she also has been a visiting researcher at UC Davis and TU Berlin. Mala, welcome. Our next panelist is Alagan Mahalingam, founder, CEO, chief software architect of RootCode. Alagan is the founder of RootCode, and in his early 20s, he worked as a researcher at international research organizations such as the Geoinformatics Center at the Asian Institute of Technology, Thailand, also the University of Tokyo, Japan, where he worked on satellite communications and solar panel optimization algorithms. Alagan was also awarded the special title of ICT Entrepreneur of the Year at the National ICT Awards in 2021, and also the Young Entrepreneur of the Year in 2024. And he's also the envoy for the government of Estonia e-residency. So I see a lot of Estonia connections here today. Last but not least, we have Sakshi Gupta. So she's the Global Government Affairs responsible for Qualcomm. She's a tech policy professional in AI and emerging technology, policy analysis, market research, and stakeholder engagement. So if we could have a please warm welcome for the panel. So first question is for Mala. As an AI-enabled XR applications and they're split between 5G and private 5G and on-premise public 5G, could you please give us some examples of XR applications in different scenarios, and what are the trade-offs in scalability, security, cost, quality of experience that you've seen in real deployments and use cases? Thank you.
So we at ArtPark have developed several applications, which is like AI and 5G enabled XR assisted medical emergency care, and also on the XR assisted facility tour. So 5G plays a major role in this both these applications, and one of the application that we have developed is that XR assisted facility tour for our art garage facility. So this Art Park stands for AI and Robotics Technological Park, and which is the DST's top innovation hub. And there are several startups incubated within this facility, and there's also a Center for Excellence in Wired and Wireless Technology. So we have several 5G test labs, and every year there is around thousands of visitors who are ready to explore our facility. So in this scenario, XR assisted facility tour will be very ideal, like visitors from diverse backgrounds will be wearing an XR, going around the facility and exploring each startup. So the inclusive experience is also included in this, and they get the immersive experience in their own preferred regional languages. And the other one other application that we have done is the XR assisted medical emergency care. Here the focus is on the to provide timely medical response to the patient who has suffering with a cardiac arrest and so on. And an SOS alert would be sent from the by the bystanders from the life circuit XAP to the first responders and the medical experts and the ambulance through 5G connectivity. Once the first responder gets the alert, he arrives at the scene with XR glasses and IoT wearables and also the AED kit. So, and while giving the CPR, the IoT patient vitals would be displayed, augmented onto the real-time video. And the real-time video would also be sent to the medical expert. And the medical expert will guide whether to continue the CPR or it could be the AED and so on. So the timely response will save multiple lives. So in this case, we have used public 5G network, but for the XR-assisted facility tour, we have used private 5G network. So the private 5G network is mainly to have on-premise edge AI applications, and this would bring the core next to the data generation. And then we can also do real-time decision making for Industry 5.0 applications. And going forward, we would like to have some of our applications to be in the open source and have it in the best place like ITU's AI for Good, right? So then the international community can access this open source AI models, and they can fine tune the models, and they can do the rigorous testing before it is bringing it to a real world deployment. That is what I'm looking forward for this.
Yeah, thanks so much, Mala. And I think this really is a good example of AI for good in action. And I think to your point, these solutions rather, they don't happen by magic. There's a lot of difficult problems to solve, and by putting these solutions in the AI for Good sandbox, that might lead to future standards, which could make them replicable, and then you could have that adoption at scale. So I'll just go to the next panelist, Alagan. Given your rich experience in developing AI solutions for partners in different geographies, can you please give us some examples of edge AI deployment in real-world scenarios, their impacts, the nuances you see in AI strategies on edge AI in the different regions? Because from your bio, you've been involved in many different parts of the world.
Yeah,
Thanks.
Sure. Yeah, I started Root Code 11 years back because I was in love with building AI solutions as a college student. And then now 11 years later, the technology that we have built is used by more than 92 million people across 27 countries, including many European governments like Government of Estonia, Portugal, and many others. We chose to build edge in many cases. One, the obvious one, to bring technology to underconnected spaces, and also to increase speed in many cases, and sovereignty. And the most interesting project that we have done recently, let me tell that story. A couple of years back, Portugal realized that their farmers, especially the small-scale farmers, didn't get enough access to advisory and intelligence to grow their crops, and things have been changing because climate change and unpredictability in growing crops. A lot of people were leaving farming. And so we built a solution from a hardware, a software product, and also an AI model. The hardware goes into the soil, so you understand the soil nutritions, and then you take pictures with the mobile app, then we can process the pictures to understand is there a problem with the plant, right? And we built, and it worked out fantastically well. And then I tried to bring that to Sri Lanka. So I grew up in Sri Lanka, and to date, a big part of our development team is in Colombo in Sri Lanka, more than 120 people. And so we went into one of these villages in the middle of the mountains of Sri Lanka, Nuwara, and I was super fascinated. And then when we tried to deploy this, we realized they don't have reliable connectivity in some corners of the villages. And our solution was worthless. And that's where we started bringing in edge. So we brought in a new version. We had a Raspberry Pi, and we started testing models like Gemma. And also we did our own convolutional networks like 2D things to figure out like where do you optimize. You don't want to use a LLM for everything, right? And by the end of it, we managed to bring the same value that the software gave to connected users in Portugal, to people who didn't even have internet in some part of Sri Lanka. And that reminded me how much edge is needed, especially in the global south. And then yesterday I was at a dinner talking to some of the development finance colleagues from DC, and somebody was talking about why don't we put computes on the wheels in a tuk-tuk. So imagine like we can't process too many things on a small device of Raspberry Pi. What if you get a tuk-tuk coming to your village every other day or once a week, and with a data center built in, with Wi-Fi LAN, so farmers can connect and do the processing. Smaller banks, smaller institutions can do. And I was like, yeah. So this week has been super fascinating. And sometimes when we think about edge, we think it's needed only in places that are not really connected, like rural parts. We have built a beautiful solution that's used in America. If you think America is well connected, you should take a road trip. When you go out of the city, you realize some parts are very disconnected. And we built, for one of our clients, we built a solution that helps rural patients who are at high risk with remote patient monitoring. And then, yeah, edge works all around the world, not just in the south. When I think about all my learnings here, because there are so many learnings building edge for multiple geographies, multiple customers, multiple communities. If I were to single out, I would single out the fact that when you are trying to do something in the edge, we shouldn't try to think of the model and go find a solution, but instead think of the task and then work backwards on how do you build and distill or fine-tune a smaller model that runs on the edge. Because in the edge, you can't do everything, right? I mean, if you are building a AI assistant for farmers, you don't want the AI to be able to tell why two of the famous CEOs didn't want to hold hands. I mean, that doesn't matter. You want it to answer about plants and agriculture. So the heavier the model is, it becomes impossible to deploy. So we work on multiple technologies to one, quantize or prune the models in a way that creates a smaller version that does exactly what's supposed to happen. Yeah. And I think the global south needs to grow with this AI transformation of the world because infrastructure takes decades, but the next few years is going to change the way we live. And that's why we are here. So I'm excited to have this conversation.
Yeah, thanks a lot. And I think what you're saying here has almost been the theme of this week, where you don't need the biggest AI or the biggest large language model. And I think if you look at the example of India, where they've managed to enable billions to have a digital ID, to enable financial inclusion, financial payments, with the public interest at heart, and with relatively low-tech solutions, you can indeed bring AI to the edge in cases that make a lot of sense. So thanks for that. Sakski, question for you. In your experience with Europe, the intersection of technology, innovation, and AI strategies, what do you think are the metrics to evaluate the usage of edge AI, such as availability and capability of hardware at the edge, and also the connectivity, privacy, and data issues that you see in your line of work?
Thank you, Fred. And let me start by saying it's an absolute pleasure to be sitting with fellow panelists and speakers who have preceded me, who are deploying edge AI and are doing research on edge AI. At Qualcomm, we are very focused on edge AI and think that that's going to be the future of how not just Global South, but globally we're going to be using AI. So, and I really relate to what you said about the way to think about deployment of AI is actually to think backwards about what is the use case that you're trying to solve. And then you think about that what is the best architecture that you want to use. Is it the just cloud? Is it on-prem? Is it an edge cloud? Or is it on-device AI? So we have to think about it from a distributed architecture point of view when we think about the use cases that we have here in the Global South. And I do want to mention one important distinction here that which was touched upon earlier also, is that when we think about AI, there's the training part of it, and then there's the inferencing part of it. Inferencing is where your thinking, processing is actually happening. So while training can continue to happen on the cloud, a lot of the inferencing, as we are seeing, is moving towards the edge. Now, in terms of availability, if I want to talk about it, I think we're increasingly seeing, and Qualcomm is deploying this at the edge of, AI being available at the edge, not from, the very basic thing that we all use every day is your smartphones, that we have on-device capabilities coming onto smartphones with 10 billion parameters models already running on device. So that means that you do not need to be connected. If you're in flight mode, you do not need to be connected on internet, and you can still use AI. So that's amazing in my point of view. We also have it coming to actually cars. So Qualcomm has developed that technology where you can now use Edge AI or it's actually in development. We have demos at the Qualcomm booth, which I'll come to later, but which you can, so Edge AI is coming to the cars as well. And it's increasingly coming to IoT devices and your smart glasses as well. So in terms of availability, I think we are seeing increasingly that it's coming to all types of devices that are connected to internet now. Now, why is Edge AI relevant? And some of my panelists have already touched on it. I think latency, security, privacy, personalization, low cost, low power are all very important factors for why Edge AI becomes important for Global South. We may not have access to as much power, we may not have access to as much water as needed, but with Edge AI, we don't have to worry about that. Apart from that, I do want to touch upon one thing, that as Qualcomm, one of the things that we have is a program called Tech for Good, wherein we partner and work with startups and small businesses around the world, where we invest in them, we mentor them. They use Qualcomm hardware to develop solutions at the edge. In fact, I do want to encourage that in Hall 4 at our Qualcomm booth, we have some of these startups who are displaying this technology. One of them examples is actually from India. It's called Raksa Health. They've actually built an on-device AI healthcare assistant, where it's for doctors and patients both, where the doctors can take down symptoms and provide solutions for their patients, and for patients to actually look up their prescriptions and be able to access all their records offline and ask questions about it. So yeah, I think that's how we're seeing the transition happen.
Thank you.
Thank you.
Thank you. Yeah, some amazing use cases. And I think it's just weeks coming out of Davos where the narrative was all about go, 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 the insatiable demands for energy. There's talk of putting data centers in space. But I think this panel also brings things a bit down to earth, where you can have AI on the edge. And of course, there's a lot of things to solve there when it comes to connectivity, when it comes to data, compute. I think there'll be a lot of standards development work that needs to emerge from this to make this work at scale. But I think your use cases and the way you're approaching the problem, especially starting from the what are you trying to solve and work backwards from that, I think it's very refreshing compared to all the headlines we've been seeing lately. And I don't see it either or. I see it as a big piece, complementary piece of the puzzle. So with that, I really want to thank the panel, and if we could have a round of applause for them. Thank you.
Thank you very much, Fred, for running the tight panel. Now we are coming to the closing. Thank you, panelists, insightful remarks. Yes? Okay, we were done, right? Can I ask a quick group photo of the panelists, please? Panelists. Yes. Thank you very much. Thank you very much. Now we are coming to the closing. There are excellent closing remarks coming. can I please request Her Excellency Ms. Lopez, Ambassador, Permanent Representative, Permanent Mission of the Republic of El Salvador to United Nations Office and other international organizations in Geneva, to please give her closing remarks.
I'm actually based in New York. Thank you. Well, good afternoon. I know that I don't have much time, but I had just to say that this discussion was very enlightening. Thank you so much for sharing everything what you're doing on the ground. And I guess that it was very clear to me that HAI means simply using an AI closer to where things happen. That means closer to people, closer to services, communities, rather than deepening only faraway systems. So amazing what you're already doing. So this can be important for development because it can work better in places with limited connectivity, as we were hearing, and it can help with speed, cost, and privacy, since not everything has to be sent everywhere. So I guess that I had to begin also with something. I am also the co-chair of the Global Dialogue on AI Governance. This is going to happen in July this year, and it's going to be the first dialogue of its kind. So trying to also bring together what we have been hearing from member states and also other stakeholders in these months, I can tell you 3 specific things connecting with what we just heard today. First, that people must remain at the center. And we have heard with all these examples. And I guess that a common message that we have been hearing also in this week is that AI should be developed and used in a way that protects but also helps people. Second, closing the gap is not a slogan. We are hearing this a lot. It requires decisive support. And I was very pleased, for instance, saying that you've been trying to replicate in some countries what it, in others, for instance. This information sharing, this is critical if we're talking about closing the gaps. And the third message, the final one, is that we should avoid a world of disconnected approaches. And this also is aligned with what I was just saying, that cooperation across different national but also regional approaches, it will help us to reduce fragmentation. So with that, I just have to tell you that we're very looking forward to see some of you in Geneva in July, so we can hear and learn more about what Edge AI it is. So it's my pleasure to give the floor to my distinguished co-chair, Ambassador Rain Tamsar. He's going to explain you very, very shortly what the Global Dialogue on AI Governance is. And this is really important, a work that we are putting a lot of effort to it. Thank you so much again for the invitation. Thank you.
Yes, hello, hello everyone. Frankly, I really feel humbled among real experts, not to say I feel helpless. So please allow me then to do a little bit of awareness raising when it comes to the first global dialogue on AI governance. And maybe this way I'll try to fit into the discussion that we've heard here today. So 3 points on my side. First, about tasking. So the tasking was to put together a distinctive, identifiable UN global dialogue with all the elements that are prescribed in the mandate. So bringing governments and stakeholders together to exchange best practices and, of course, to focus on cooperation. And to execute it back-to-back with ITU AI for Good summit in July in Geneva. Produce co-chair summary. So this is what we are going to do. So far we've engaged with member states, with stakeholders, multi-stakeholders, and from member states we've kind of gathered 3 different approaches, I would say a little bit. Risks versus opportunities, state-centric approach versus multi-stakeholder approach, closing AI divide versus free market innovation. But we also were able to pick up 3 convergences. practical outcomes preferred over endless theoretical discussions, alignment with existing UN processes, avoiding duplication, clear timeline, formats, and thematic focus to produce actionable insights. And the unified element, I would say, in these discussions is that the dialogue needs to be inclusive, and capacity building was absolutely crucial element. That is, of course, one of the most important things to Global South. So from multi-stakeholders, what we've heard, the keywords, so to say, were trust, transparency, no duplication, interoperability, equal access and participation for everyone, rooting the dialogue in human rights, and to be of a practical value, and innovative in form. So what we are going to do, we will guide the discussions, but we will not predetermine the outcome. It's for member states, it's for you, for stakeholders. And of course, we will engage also with international scientific panel that was also established through the same resolution. We will rely on member states and your wisdom. We would need to collect this wisdom somehow. And this is something that we are going to do because we would need this wisdom so that the dialogue would be really inclusive. We would come up on certain point with a roadmap to Geneva where you would see what are the building blocks towards a dialogue and what are the opportunities to engage into dialogue. And of course, I very much hope that all these fantastic ideas, and frankly, I mean, chapeau to the panel, because you're already making or changing life on the ground, and it's absolutely fantastic. We really need this also to inform our dialogue, and so that the dialogue would be also result-oriented on the ground. Thank you very much.
Thank you very much, Your Excellencies. At this point, I would like to call Fred to give out the mementos, if you don't mind, Fred, please. And can we have the mementos for Brajesh? Ranjita, please. Moala? Can I request nodal officer to please felicitate Fred? Yeah.
We have an event with ministers.
Yeah, we are done. We are done.
So
yeah.
we need to prepare.
Thank you very much for attending the session. Session is closed. Thank you.
Dear panelists, you are requested to please move out as the next session is going to start very shortly. Thank you.